This is Dr. Shankaraiah from Department of Physics. In today's presentation, I am going to discuss about bottom-up fabrication methods. So, what is this bottom-up fabrication method, and how many processes or how many different methods are available in bottom-up fabrication method? So, in this bottom-up approach, we discuss three methods that are used for the fabrication of nanostructures or nanomaterials from nanoparticles. So, basically, bottom-up fabrication method, there are three different methods. Okay, so there are three different methods. So these three methods are used to fabricate nanostructures or nanomaterials from nanoparticles or atoms or molecules. So we are going to start with atoms or molecules or nanoparticles, and we are going to construct bulk materials, for example nanomaterial or nanostructures. So that is bottom-up fabrication method or bottom-up approach. So in bottom-up approach, we are going to start with atoms or molecules. We are going to start with atoms or molecules or small nanoparticles, and then we are going to fabricate clusters, and then we are going to fabricate nanomaterials or nano clusters or nanostructures. Okay, so in this bottom-up fabrication method, there are three different methods: sol gel method, precipitation method, and combustion method. Sol gel method, precipitation method, and combustion method. So these are the three different methods that are available in bottom-up fabrication approach. Okay, so let us see what are all these three different methods, and how do we fabricate nanomaterials or nanostructures from these atoms or molecules from the beginning. So the first method in bottom-up approach is sol gel method. Okay, so sol gel method. Sol gel involves the formation of a colloidal suspension. Formation of a colloidal suspension and gelation of the solution. So this is solution. Okay, so solution. So SOL is basically solution. Okay, so formation of colloidal suspension and then gelation of the solution. Colloidal suspension is nothing but a solution. Okay, first we are going to form a colloidal suspension or solution, and then we are going to wait for the gelation of the solution, and then to form nanopowders in a continuous liquid phase gel. Okay, so from this solution, we are going to wait for the solution to get gelated, and then after this gelation, we are going to get nanopowders from liquid phase gel. Okay, so the first step in sol gel method is that sol gel. Sol means solution, gel means gelation. Okay, first we are going to prepare a solution. This is step 1. Step 1 is to prepare solution, okay, which is colloidal suspension. Colloidal suspension. Our toothpaste is also a colloidal suspension. Milk is also one of the colloidal suspension. Colloidal suspension is nothing but you have solution and solvent. So one of them is going to hang or suspend in another solution. Okay, so one is solvent, another one is solution. First we are going to prepare the solution, step 1, and in step 2 we are going to wait for the gelation of solution. So this solution going to get gelated and form a gel which is in the liquid form. Okay, gelation to get gel. Okay, so gel is nothing but a network of polymer network. Okay, so once we get this gel, so from this gel we are going to get nano powders. Okay, so the start, you can think of that as third step. Third step is nano powders or nanomaterials. Okay, so as the name suggests, so sol gel method. So first, the first step in sol gel method is preparing a solution which is like a colloidal suspension. The example of colloidal suspension is milk or toothpaste, right? In which one type of the particles are suspended or hanging in another type of solution. Okay, so that is colloidal suspension. So the first step is preparing a solution, and then second step is wait for the formation of gelation or gel. So this solution is going to get gelated or to form a gel which is in the liquid form. So that gel, the time we need to wait to form a gel is called gelation time, and then finally we are going to get nano powders from this gel. Okay, so I have defined here what is a colloid. A colloid is a mixture in which one of an insoluble substance of particles are suspended throughout another substance. Okay, so there are two types of substances. One type of substance is not insoluble. It is not going to solve. So it is not going to mix with other solution. So it is insoluble substance, and this insoluble substance of particles are suspended throughout another substance. Okay, so one type is hanging on another type of solvent. Okay, so that is called as colloidal or colloid mixture, colloidal suspension. So initially a homogeneous solution of a material is prepared and used as precursor for nano fabrication. Okay, so now we understand what is a colloid. Colloid means there are two different types of substances, substance 1 and substance 2. So there are two substances in colloid or colloidal suspension. So out of these two substances, one type of substance is not soluble in another. So I am saying substance 1 is insoluble. It is not going to get soluble in another one, and substance 2 is solvent. Okay. So one type of substance of particles are going to hang or suspend throughout another type of substance, and the other second substance is a solvent. Okay, so that is a colloid. So in this solvent method, initially we are going to prepare a solution of a material, and we are going to use that solution as a precursor for fabrication of these nano powders. Okay, so let us see how we are going to prepare that. First we have started that we are going to prepare a solution, right? So yeah, so first we prepare a solution. So the solution is deposited on a suitable substrate by spraying, dipping or spinning. Okay, so the solution is deposited on a suitable substrate by, you can deposit this solution. We have prepared a colloidal suspension or solution, and this solution is going to get deposited on a substrate, on a suitable substrate by spraying, dipping or spinning. So you can spin the substrate so that the solution is deposited. You can spray the solution to deposit on the material. You can dip it. You can take the substrate and dip it in the solution so that the solution is deposited on the substrate. Okay. Now once we deposit the solution on a substrate, it is kept for a while for gelation. Once we deposit this solution on a substrate, we are going to wait for some time, which is called aging time or gelation time, right? So we are going to wait for a while until this substrate, which is where solution is deposited, to get gelated or to form a gel. Once we have this, during this gelation time, the material gradually loses its fluidity and undergoes a transition from viscous liquid state to elastic solid state. Okay. Now, first we prepared solution, and then once we prepared the solution, we have taken a suitable substrate, and then the solution is deposited on the substrate. There are different methods to deposit solution on the substrate. For example, you can spray the solution on the substrate, or you can dip the substrate in the solution, or you can spin. You can spin the substrate so that the solution get deposited. So there are different methods to deposit solution on the substrate. Once we prepare this, once we deposit the solution on the substrate, we are going to wait for some time. That time is called as gelation time. Okay, what happens during this gelation time? During this gelation time, the material gradually loses its fluidity and undergoes a transition from viscous liquid to elastic solid state. Okay, so basically during this gelation time, there is a transition in which the viscous liquid is going to change to a elastic solid. Okay, so that kind of transition is going to occur during this gelation time. Okay, so basically the solution which is deposited on the substrate is going to become like a gel. This time depends on the viscosity, temperature, etc. of the solution. So how much time do we need to wait for the solution to get to form a gel? So that time depends on the viscosity, temperature, and type of the solutions. Okay, so these are the parameters that can affect the gelation time. How much time do we need to wait for the solution to get gelated? Okay, so this is the schematic of sol-gel method, in which you start solution or precursor. First, through condensation, you form this solution in which you have one type of substance or particles are suspended through another. So this is actually collide. So these particles are hanging or suspended in another type of substance, which is a solvent. Okay, so if you have two types of solution of precursors, you can condense. So one of the type of substance or particles are going to get condensed, and so then they are going to suspend it through another substance which is solvent. Then we are going to wait for the gelation time. So this is the gelation time. Once you have solution, then we are going to wait for the gelation time. So during which this elastic viscous liquid is going to form into elastic solid. Okay, so during the gelation time, viscous liquid is going to form elastic solid. So that means you are going to see the transformation of the solution that is deposited on the substrate into a gel. Okay, so that is gelation time. Once during this after this gelation time, you see there is a gel. Gel is nothing but network of polymers. So you see there are polymers, formation of polymers. So there are network of these polymers, supercritical. So once you have this gel, you can do different types of drying. By doing different types of drying, you can prepare different types of materials. From this gel, you can prepare dense ceramic, or you can prepare powder, right? So so these are two different types of materials. Or you can also prepare thin film also. You can prepare thin film, you can prepare fibers. Different types of materials can be prepared using this sol-gel method. So using the solution itself, once you have collide, using the solution itself, you can prepare dense thin film, or you can prepare fibers, or you can also dry and prepare powder from this solution itself. Once you have colloidal suspension or solution in which one type of substance or particles are hanging in another type of substance which is a solvent, then you can dry this, you can spray deep or spin coat, and then you can coat these particles onto a substrate, and then you can prepare a thin film. Okay, so you can prepare a thin film, or you can draw these to prepare fibers, or you can dry this solution to prepare powders. Okay, so this is from solution itself. Or if you wait for gelation time, you are going to find a gel which is having network of polymers. So from this gel, if you dry this gel, you are going to prepare again a small the thin wires, and then these wires we can grind them, and then small grains or small wires. Then once we grind, we can get powders from the gel also. So you can prepare powder from the gel or from the solution itself, or you can supercritical drying of this gel can give you different types of long polymers, so aerogel, and then sinter them to find these dense ceramic materials. So so this is a schematic of sol-gel method. So in sol-gel method, once you prepare the solution, from the solution itself, you can prepare thin films and fibers or powders from the solution itself by drying or coating. Or if you wait for the gelation time, you are going to get a gel. From the gel also you can prepare powder, and you can supercritical drying. By doing the supercritical drying of this gel, you can prepare dense ceramic material. So you can prepare variety of materials using this Sol-Gel method. Okay, so the steps involved in Sol-Gel method for nanoparticle formation. Okay, so these are the steps that are involved in Sol-Gel method. So the desired colloidal particles are dispersed in a liquid to form a solution through hydrolysis. So first a solution is prepared. Desired colloidal particles are dispersed in a liquid to form a solution. We are going to disperse particles into this liquid to form a solution through hydrolysis. The deposition of the solution onto the substrate by spraying, dipping or staining. Once we form this solution, we are going to deposit this solution onto different types of substrate using variety of methods, for example spraying, dipping or staining. So the particles in the solution are polymerized through removal of the stabilizing components and produce a gel through condensation. So we are going to prepare gel, or we are going to wait for the gelation time of this solution, after which we have a gel. So the final heat treatments pyrolyze the remaining organic or inorganic components and to form amorphous or crystalline nanoparticles coating on the substrate. So this is aging or drying. Okay, so finally we are going to heat this gel. By heating this gel, we are going to remove some of the organic or inorganic components, after which we are going to find crystalline or amorphous nanoparticles in the substrate. So the main benefits of this Sol-Gel processing are the high purity and uniform nanostructures is achievable at low temperatures. It is normally used to produce metal oxide nanomaterials. So the main advantage of this Sol-Gel method is that you are going to get high purity, highly pure nanostructure using Sol-Gel method, and you can achieve this. You can produce different types of metal oxide nanomaterials using this Sol-Gel method. So this is one of the most important technique that can be used in bottom-up approach. The second approach in bottom-up method is the combustion method. So this technique is widely used to obtain metal oxide and insulator nanoparticles, nanomaterials. Okay, so combustion method is basically used to find or fabricate metal oxide and insulator nanomaterials. In this technique, first one should make a solution with solutes and solvents. Sometimes making solution may require stirring provision. Okay, so first we are in combustion method. First we are going to prepare a solution. So with solutes and solvents, so we are going to prepare a solution, and then the solution is heated, and once the solution reached auto ignition temperature, it will start to burn by indication of flames with evaporation of some gases. Once we prepare a solution, solution contains solutes and solvents. Okay, one of them is going to hang this suspended through another. So that is a solution. Once you have solution, you heat this solution, and you heat this solution until the solution reach auto ignition temperature. Auto ignition temperature means that you are going to see the solution itself is going to start burning. Okay, so that is called auto ignition. So once we start heating, we keep on heating the solution until the solution start burning itself. Okay, so once it start burning with flames, then we will find some evaporation of the gases. Okay, so after completion of the burning process, the remaining ash will give us the required nanomaterials. Okay, so after burning of this solution, so then we will find some ash. So that ash will give us a particular type of nanomaterial, depends on what kind of solution we have prepared. Okay, so this is a schematic of this combustion method, where we prepare a solution, and then by heating the solution, this solution is going to burn itself. After this burning of this solution, we are going to get a powder from which we can find different types of nanomaterials. Okay. So this is the schematic of combustion method. So the last method in bottom-up approach is precipitation method. So the principle of this technique is getting the precipitation of our desired materials after reactions occurred by mixing solutes and solvents. So we are going to form or prepare or fabricate a nanomaterial through the process of precipitation. Okay, so we are going to use this precipitation method through which we are going to prepare nanomaterial by mixing solutes and solvents. Okay, so in this case, the precipitation of ions may occur slowly by washing with some suitable reagents or drying up the precipitation. One can get the required nanomaterials. It is widely used to synthesis metal oxide and insulators with broad band gap along with suitable surface. So precipitation method basically used to prepare metal oxide and insulator nanomaterials as in combustion method, but here we can prepare this metal oxide in an insulator nanomaterials with broad band gap with suitable surface. So to prepare that high band gap, broad band gap nanomaterials, metal oxide insulator nanomaterials, we can use this precipitation method. So in this process, in the precipitation process, the desired component is precipitated from the solution. Okay, so the desired component is precipitated from the solution, right? So first, precipitation is a formation of a solid in a solution. Okay, so what do you mean by precipitation? Precipitation means that we have prepared a solution in which you have solute and solvent. Okay, so one in the process of in the method of precipitation, first there is going to we are going to see a formation of solid in the solution. Okay, so this solid is called precipitate. The solid that is formed in the solution is called as precipitate. Okay, first we need to prepare a solution, and in the solution we are going to see a formation of solid which is called as precipitate. So a precipitation reaction occurs when the water solutions of two different ionic components are mixed and insoluble solid separates out the solution. So in the precipitation reaction occurs when water solutions of two different ionic compounds are mixed. When two different types of ionic compounds are mixed, an insoluble solid separates out of the solution. So yeah, so because of this precipitation reaction, we will see the solution formation of this solid which is called as precipitate. So this is the schematic of the precipitation method, where we will see precipitates. So the formation of precipitates, which is a nano material. Yeah, so these are some of the properties of nanomaterials. So physical properties, their decrease in melting point with size, catalytic property, better catalytic efficiency through higher surface to volume ratio, electrical properties, increased electrical conductivity in ceramics and magnetic nanocomposites, increased electrical resistance in metals. Okay, so nanomaterials have different types of properties. Okay, so when we go from bulk to nano, these are the properties that we will see changing, right? So magnetic properties, when we go from bulk to nano, increased magnetic coercivity up to a critical grain size, superparamagnetic behavior. Mechanical properties, improved hardness and toughness of metals and alloys, ductility and superplasticity of ceramic materials. Optical properties, what are the changes that we see in optical properties? For example, when we go from bulk to nano. Spectral shifts of optical absorption and fluorescence properties, increased quantum efficiency of semiconductor crystals. What are the properties that change in biological properties? Increased permeability through biological barriers, membranes, blood-brain barrier, etc. Improved biocompatibility. Okay, so for example, biocompatibility, when you go from bulk to nano, so you will see these nanomaterials are biocompatible. Okay, so these are some of the properties of nanomaterials. So in this presentation, so these are some of the reference textbooks and reference books. To summarize, in this presentation, basically I have discussed about bottom-up approach method, bottom-up approaches. Okay, so bottom-up approach. In bottom-up approach, basically we are going to start with atoms or molecules or nanoparticles. This is bottom. We are going to up. So bottom up. So small atoms or molecules to big materials, bulk materials. So we are going to prepare or fabricate bulk materials starting from atoms, molecules or nanomaterials. So this is the bottom-up approach. In bottom-up approach, basically there are three different types of methods. So first method is Sol-Gel method. So Sol-Gel method, and then second one is combustion method. And third one is precipitation method. So in sol gel method, basically sol gel method. Sol gel method, first we are going to prepare a solution, okay, and then we are going to wait for the gelation time. So that waiting time is called gelation time. During this gelation time, there will be a transition from viscous liquid to elastic solid, so solution will become a gel. Okay, so this gel can dry up. Supercritical drying of this gel, we can find different types of materials. For example, ceramic materials. We can find nano powders, right? Nano powders, and from the solution itself, by drying the solution or spin coating or dipping, we can prepare thin films. We can prepare thin film, or we can also prepare optical fibers. We can prepare optical fibers, for example, using this sol gel solution. Using the solution itself, optical fibers you can prepare, or you can also prepare powders. Okay, so sol gel method is a useful method way to prepare different types of materials. And then the next one is combustion method, where we are going to first prepare a solution in combustion method. So combustion method. So in combustion method, first we are going to prepare a solution, okay, with suitable solvents and solutes. Then this solution is heated. Solution is heated to reach auto ignition temperature. Heated to reach auto ignition temperature. Auto ignition temperature. Auto ignition means the solution itself start burning, and then we will find some ash from which we can prepare nano material. So in combustion method, basically we first prepare a solution with suitable solvents and solutes, and then we are going to heat the solution to reach auto ignition temperature, at which the solution start burning itself, and then after this burning we will find the ash, and this ash is used to prepare nanomaterials. So the last one is precipitation method. So in precipitation method, basically we are going to prepare solution again. So in precipitation also we are going to prepare solution, this solution with suitable solvents and solutes, and this solution, in this solution will we mix ionic compounds because of this reaction, precipitation reaction. This ionic when we mix these ionic compounds, we will find a formation of solid which is called precipitate. Okay, so this is what we will see as a nanomaterial. So basically we have discussed about bottom up approaches, sol gel, combustion and precipitation methods, and also we have discussed some properties of so properties of nanomaterials also we have discussed in this presentation. Properties of nanomaterials. Okay, so in the next presentation I will discuss the next topic in nanomaterials. So with that we are going to end up this module 5, which is nanotechnology, and then I will discuss some numerical problems also on nanotechnology. Okay, so with that we will complete this module 5, which is nanotechnology. Yeah, so I am going to end here this presentation here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.